guys, welcome back to Wong Chemistry channel. This is the part 6 video of your topic 7.1, and in this video we are going to discuss about buffer solution. We are going to discuss about the concept or the theories about your buffer solution. Okay, and we have two types of buffer solution. The first one is your acidic buffer and the second is your basic buffer. Okay, so first and foremost, what made up your acidic buffer solution and what made up your basic buffer solution? Your acidic buffer solution will be formed when you have your weak acid mixed with its conjugate base. It must mix back with their conjugate base, the pair of the conjugate base. Okay, so for example, my weak acid over here is a CH3COOH. The conjugate base of this weak acid will be CH3COO-Na, or sometimes we will just write it CH3COO-. Okay, I hope you remember in the first video we talked about the conjugate acid-base pair. Okay, so from the acid, how do I get the conjugate base? Simple, from the acid, we will get the conjugate base by donating 1 H+. Once you donate 1 H+, that is what we call conjugate base. So bear that in mind, your acidic buffer will be formed when you have your weak acid mixed with its own conjugate base. And since it's an acidic buffer, therefore the pH value for this buffer solution must be less than 7. Because it's an acidic buffer, therefore the pH must be less than 7. Next, how about basic buffer? So if acidic buffer is made up by the weak acid, therefore your basic buffer will be definitely coming from your weak base. Can you see that? So acidic buffer is the weak acid plus its conjugate base. So basic buffer will be the weak base with its conjugate acid. Okay, so again, like the acidic buffer, there must be in the correct pairing. And for example, the weak base that we always come across, ammonia. So who is the conjugate acid? The conjugate acid can be your NH4Cl, or sometimes we will just write it as NH4+. Like the first video that we discussed in this topic, your conjugate acid-base pair. So from the base, how do I form my conjugate acid? Simple. The base will accept H+. When the base accepts the H+, then you will form the conjugate acid. Okay? So bear that in mind, in a buffer solution, the weak base and the conjugate acid must be in their pairing. Okay? Same goes to your weak acid and also the conjugate base in your acidic buffer. They must be in their respective pairing. Okay? And since it's a basic buffer, what do you think the pH value of this buffer solution? The pH value of this buffer solution will be more than 7. Due to the presence of your weak base, that is the reason why it's a basic buffer. That's why it must be pH more than 7. So this is the two types of buffer that we can have. Your acidic buffer and your basic buffer. And make sure you know how to differentiate an acidic buffer and a basic buffer. Acidic buffer must be between weak acid and its conjugate base. Basic buffer must be between weak base and its conjugate acid. Okay, simple. And the pH value for both of the buffer solution is just something very common, where acidic pH less than 7, where basic buffer pH more than 7. Simple. So after you know that we have two types of buffer, your acidic buffer and your basic buffer. So the next question will be, what is actually a buffer solution? So buffer solution is a solution that have the ability to maintain its pH when a small amount of strong acid or strong base is added to the buffer solution. Bear that in mind, when I say maintain, it still can change slightly, but the changes is very, very small, okay? Generally, the pH of the solution is not changing, even though a small amount of strong acid or strong base is added to it. So let's take a quick look. So I have a buffer solution over here. Let's say the pH of my buffer solution is 7, okay? When I have a strong acid added into my buffer solution, I add in a strong acid. A small amount of strong acid is added and look at the pH. The pH will drop slightly. It will drop very slightly, only 0.1. But generally, the pH will maintain, right? So from 7, it will only change to 6.9 when you have a strong acid is added. But let's look at a solution that is not buffer over here. When you have a solution that is not buffer, I started off the pH again with 7. Same process, I have a strong acid added into my solution. Look at the pH value changes. I'm changing all the way from pH 7 to pH 4. The pH dropped drastically. Why the pH will drop drastically? Because the strong acid will have a lot of H+. Okay? So the H+ will cause the pH to drop drastically. That is the difference between a buffer solution and an unbuffered solution. And the same thing will happen when you are adding in your strong base. When you have your strong base added into your buffer solution over here, the pH originally is 7. And then when you add in a strong base, the pH only changed to 7.1. The pH right now increased slightly. It will only increase very little, only 0.1 increment, because it's a buffer solution. But what happens when it's an unbuffered solution? When it's an unbuffered solution and you add in the same amount of strong base, look at the pH changes. The pH from 7 will increase drastically to 10.5 and the pH over here increase drastically. And the changes of pH is very large. In the other words, the solution that is unbuffered over here not able to maintain its pH. Okay? But a buffer solution, the job of a buffer solution is to maintain the pH. We are trying to minimize the changes of the pH if there is any changes happen to the solution. That is the function of buffer solution. Okay? Next, let's see how an acidic buffer can maintain its pH when a strong acid or strong base is added. So, just a kind reminder, acidic buffer means the solution is having your weak acid and its conjugate base. And the pH must be less than 7 because it's an acidic buffer. So, let's see what happens when a small amount of strong acid is added. So, right now, into this acidic buffer, I'm adding in a small amount of my strong acid. Let's say the strong acid that I have today is HCl. When I have a small amount of HCl is added, who do you think will neutralize the HCl? I have the presence of my weak acid in my buffer. I have the presence of my conjugate base in my buffer. And hydrochloric acid is an acid. So who will neutralize the hydrochloric acid? Obviously, the base. So your hydrochloric acid will be neutralized by the conjugate base in your buffer solution. Okay? So, in the other words, the H+ that produced by your hydrochloric acid will be completely neutralized by the conjugate base that you have in your acidic buffer. And when the H+ is neutralized by the conjugate base, what will be produced? You will reproduce your weak acid. As simple as that. Okay? And you can see over here, the things that involve is the addition, your acid, and then the conjugate base that you already have in the beaker, and then the weak acid that you already have in the beaker. See that? And since the conjugate base is used to neutralize the acid, therefore, after the addition, the concentration of your conjugate base will decrease. Why the concentration will decrease? Because it's used to neutralize the acid. And vice versa, the concentration of your weak acid will increase. Why the concentration will increase over here? Because we are producing the weak acid. So you have slightly more weak acid in the acidic buffer solution. Make sense? Simple. And whenever the small amount that you add in is an acid, alright, when the small amount that you add in is a strong acid, the pH will drop slightly. Why the pH will drop slightly? Because you will have your weak acid increase slightly. Okay? That's why the pH will drop slightly. Make sense? Simple. So next, what would happen when you have a small amount of your strong base is added into the same buffer? Let's say my strong base over here is my KOH. Alright, a very simple and common strong base. So when your KOH is added, who do you think will neutralize the KOH? Guys, it's just something very common sense. In your acidic buffer, you have your acid and your conjugate base. And right now, what I have is a strong base. Who do you think would neutralize my KOH? Just choose acid or base. Obviously, the acid. So KOH will neutralize by your weak acid, right? Base will always neutralize by acid. Acid will always neutralize by base. Simple. So KOH will neutralize by the weak acid. In the other words, the OH minus that produced by the KOH will be completely neutralized by your weak acid. And vice versa as above. During this neutralization, what will produce? Simple. What do you have in the beaker? Conjugate base. As simple as that. Okay? So when your weak acid neutralizes the strong base, we will then produce our conjugate base. And as above, we are just playing around with what we have in the beaker. Can you see that? There is no third party. Okay, we are just playing around with the species that you have in your buffer solution. If you are using weak acid, you produce conjugate base. If you are using conjugate base, you produce weak acid. That's it. And what would happen to the concentration of your weak acid? Since your weak acid over here is used to neutralize the base, therefore the concentration will decrease because it's being used. And vice versa, the concentration of your conjugate base over here shall increase. Why is increasing? Because we are producing the conjugate base. Simple. Alright? And since conjugate base is the one that increased slightly, therefore the pH of your buffer solution right now will also increase slightly. Bear that in mind. The changes of pH is very, very minimum in the buffer solution. Okay? The pH will only drop or increase very, very slightly. Okay? And that is how your acidic buffer maintains its pH when you have a strong acid added into the acidic buffer or when you have a strong base added into the acidic buffer. Okay? No matter the addition is a strong acid or strong base, your acidic buffer will still have the ability to maintain its pH. Okay? Simple. How about basic buffer? It's gonna be the same as your acidic buffer, just slightly different because in the basic buffer, your solution having your weak base and also your conjugate acid. And another difference is the pH right now is more than 7 due to the presence of weak base and because it is a basic buffer. Okay? So let's see what happens when you have a small amount of strong acid is added. Same thing, let's use hydrochloric acid. So, since hydrochloric acid is a strong acid, it's an acid. So, who do you think that will neutralize your acid? You have a selection of base or acid. Because when this thing is added into your buffer solution, in your buffer solution, you only have your weak base and your conjugate acid. So, who will neutralize the strong acid? Obviously, your weak base. Right? So hydrochloric acid will be neutralized by your weak base. Okay? So in the other words, the H plus that produced by the hydrochloric acid, all the H plus will react with the weak base. It will all neutralize by the weak base. And the same thing like your acidic buffer. If weak base is used to neutralize the strong acid, what will be produced? Simple. Conjugate acid. We will only play around with the species that you have in your buffer solution. And the same story. When the weak base is used to neutralize the strong acid, so the concentration of weak base will decrease. And then the concentration of your conjugate acid, in this case, will increase because it's produced during the neutralization process. As a result, the pH over here will drop slightly. Why the pH will drop slightly? Because your conjugate acid is produced. Okay? Simple. Very, very simple. And the same thing over here. What would happen when you have a small amount of strong base is added? Let's say the same base we are using, KOH. Okay? So right now in the same buffer solution, you are adding in KOH. So what would happen to the pH value, and who do you think will use to neutralize the strong base? And guys, it's a strong base. So who do you think will neutralize the base? Your base or your conjugate acid? Obviously, your conjugate acid. So KOH will be neutralized by your conjugate acid. And what we mean over here is the OH minus produced by the KOH will be completely reacted or completely neutralized by the conjugate acid. Okay? And what will be produced? The same story, guys. We play with the same species in your buffer solution. Therefore, we will produce your weak base. Can you see that now? Okay? And because your conjugate acid is being used to neutralize the base, therefore, the concentration of your conjugate acid will decrease. Vice versa, your weak base is produced during this process. Therefore, the concentration of your weak base will increase. As a result from that, your pH value will then increase very, very slightly. The pH value will increase very little because the function of a buffer solution is to minimize the changes of pH. We are trying to maintain the pH of your solution. So when your pH change, drop or increase, it will only change very, very slightly. Okay? And this is how buffer solution maintain its pH value when a small amount of strong acid or strong base is added. Simple? Easy. So let's try our first example over here. I have a solution and I know that it's a buffer because I have a pair of my conjugate acid base pair. And over here, this is my weak acid. Very obvious that it's a weak acid because I can produce the H+, right? And since that is my weak acid, obviously this is my conjugate base. Agree? And once you come across a buffer solution, the first thing that you do, identify the type of buffer. Is an acidic buffer or is a basic buffer? Over here, it's made by a weak acid. Obviously, it's an acidic buffer. So make sure you can identify that. And since it's an acidic buffer, you should know the pH value of this buffer solution must be less than 7. Okay? And the question is asking, when a small amount of KOH is added, what would happen? Okay? Let's see. KOH is a strong base. So over here, when it's a strong base, I will produce OH minus. Agree? So the first thing, we need to identify who will be used to neutralize the strong base. So KOH will be neutralized by your weak acid or your conjugate base. Come on guys, it's a strong base. We will definitely choose the weak acid. Agree? So KOH will be neutralized by your weak acid, and your weak acid today is your C6H5COOH, your benzoic acid. Okay? And once you have determined who will neutralize your strong base, then we go for the equation. So your OH minus over here will then completely neutralized by your weak acid. So what will happen in this equation is you must produce your conjugate base. So your conjugate base that will produce is your C6H5COO minus. The H plus in the weak acid will be used to neutralize the OH minus. That's why you will be missing the H plus and then forming a byproduct of water. Can you see that? Okay, that is how your weak acid will neutralize the KOH. Simple. As a result, what happened to the concentration of your benzoic acid over here? Since the benzoic acid is used to neutralize the strong base, therefore, the concentration will decrease. Vice versa, your conjugate base, your C6H5COO minus, is produced during the neutralization process. Therefore, the concentration will increase. Make sense? And the one that increase is your conjugate base, guys. And therefore, the pH value over here shall increase slightly. So when you calculate the pH value will increase very, very slightly from the original pH value that we have. Okay? And this is how we answer your buffer solution qualitatively. Qualitative means we are not doing calculation, but we are using theory. So this is the type of qualitative question in your buffer solution. Simple, easy. Next example that we have are having C6H5 again. So it's still your weak acid, the same weak acid, alright? Therefore, over here will again be your conjugate base. So as always, when you have a buffer solution, you need to determine the type of buffer. It's a weak acid over here. Therefore, this will be my acidic buffer. And since it's an acidic buffer, you should know the pH value will be less than 7. Okay? And in this question, a small amount of your HCl. Your HCl over here is your strong acid. And the strong acid will definitely have the presence of your H plus. Okay? So, your HCl is added into your buffer solution. So, your HCl over here will definitely neutralize by who? It's an acid. So, it will definitely neutralize by your conjugate base, which is your C6H5COO minus. Okay? That is my conjugate base. Because hydrochloric acid is an acid. So when it's an acid, it will then neutralize by the base. Okay? So the equation is the hydrochloric acid will produce H plus. The H plus will be neutralized by my conjugate base. And my conjugate base is my benzoic ion, C6H5COO minus. Then I will form what as a product? Very simple, we'll play around with the species in your buffer solution. Since I'm using the conjugate base, therefore, I will be producing my weak acid. So, I will produce my C6H5COOH. Can you see that right now? Very, very simple, okay? That is my conjugate base. So, I'm using my conjugate base to neutralize the acid. So, what will be produced? I will be producing my weak acid. We are just playing around with the same species, guys. Alright? If you are using A, you will be producing B. If you are using B, you will be producing A. That's it. Okay? As a result, the concentration of your C6H5COO minus over here will decrease because it's being used. And vice versa, the concentration of your weak acid over here will increase because it's being produced. And due to the production of your weak acid over here, therefore, the pH value of your buffer will drop slightly because it's an acid. So when it's an acid, the pH will be lower down. Therefore, the pH will drop slightly. Okay? Simple. Very easy. Right? Next question over here. You are having your NH3 and also your NH4Cl. Knowing that your NH3 is a weak base, guys, therefore, your NH4Cl is a conjugate acid. Okay? And like we said before, when you have a buffer solution, the very first thing, what type of buffer? Is a weak base, straight away basic buffer. And since it's a basic buffer, what do you think the pH value will be? More or less than 7? It's a basic, definitely more than 7, right? And the question is saying right now, what would happen when a small amount of KOH is added? Knowing that your KOH is a strong base, and as always, quite obvious and significant, strong base means we have OH minus, and the same story. So, who will neutralize your KOH? Come on, it's a base. Certainly, your conjugate acid. Base will always neutralize by the acid. Acid will always neutralize by the base. Common sense, right? So, your KOH will be neutralized by your NH4Cl. Okay? Or, you can write it as NH4 plus. Same thing, it's the conjugate acid. And the equation shall look something like this. The KOH will have your OH minus produced, and the one that we want to neutralize is actually the OH minus. And we will use the NH4 plus over here. So, your conjugate acid will neutralize the OH minus base. And what do you think produce? Obviously, we will be producing the species that we have in our buffer. So, we will produce our weak base. Okay? So, what left is your water. So, water as a byproduct over here. Make sense? Simple. As a result, what will happen to the concentration of your NH4+? The concentration of your NH4+ over here will decrease because it's being used. Vice versa, the concentration of your NH3 over here will increase because it's being produced. And knowing that your NH3 is a weak base over here, so weak base is increased and produced. What do you think happened to the pH? pH will definitely increase slightly. Why increase slightly? Because it's a base. When it's a base, the pH will always be slightly higher, right? Simple. Okay? As easy as this. And last but not least, the last example using the same buffer solution, your NH3, that is my weak base, using the same conjugate acid, of course, because it's the same weak base. So that is my conjugate acid, okay? And because it's a weak base, therefore, it's a basic buffer. And since it's a basic buffer, pH will be definitely more than 7. This is always the first thing that you do when you come across a buffer solution, okay? So right now, the changes is I'm adding in a small amount of my strong acid. So, small amount of hydrochloric acid obviously is your strong acid. Knowing that strong acid means the presence of H+, okay? By now, you should know who will be used to neutralize the hydrochloric acid. Hydrochloric acid is an acid, quite obvious, I guess. Therefore, who will be used to neutralize it? Obviously, the base. Agree? So, hydrochloric acid will be neutralized by my ammonia, which is my weak base. Okay? And in terms of equation, your H+ that produced from your hydrochloric acid will then be neutralized by the ammonia as a weak base in your buffer solution. And who do you think you will produce? Very obvious, your NH4+, which is your conjugate acid in your buffer. Can you see that at this moment? We only have 2 species in your buffer. Okay? And as a result, what would happen to the concentration of your ammonia? Since your ammonia is being used, the concentration of ammonia will decrease. Agree? And vice versa, the concentration of your conjugate acid NH4 plus over here will increase because it's being produced. And because the conjugate acid is produced, guys, what happened to the pH value? The pH value will definitely drop or decrease slightly. And because you are producing conjugate acid. And bear that in mind, again and again, the pH that we change is only very, very slightly. What are we trying to prove in your buffer solution is how your buffer solution maintain its pH. So when the pH drop or increase, the changes will be extremely small. Alright? Simple, easy. And that's it about the theory of buffer solution. Okay? Calculation will be in the next video. So I hope this video able to help you to understand what is actually buffer solution and how buffer solution can maintain its pH. If you still have any question regarding buffer solution, drop it in a comment below and I'll get back to you as soon as I can. Remember to like the video, subscribe to my channel, and thank you for watching, and I'll see you again in the next video.
TunePocket.com